Okay, so 2.3, working with subtracting integers. So yesterday you worked with adding integers together, now we're subtracting them. And the really nice part about these two sections, they're very, very similar to one another. Very similar idea, very similar process, except now we just have some negatives going in as all. So our core definition that we have for subtraction is to add the opposite or add the negative. So if we have a and b are values, whatever they may be, then a minus b is the same as saying a plus a negative b. And again, this is our main core definition that we have for subtraction. You can write it with these double signs showing up, but I highly recommend you avoid that if you possibly can. Again, as my reminder with this, avoid double signs if possible, and if they do show up in a problem, then rewrite them out. Because again, I think they're a little weird to work with, and getting rid of those, it makes life easier, I think, as you're going through and solving problems like this. At least my personal experience was having double signs showing up in a problem made me have a lot of errors showing up, and I lost a lot of points on that. So I don't want you guys making my mistake with that if you can help it. So we're going to go into a couple examples, again, very similar to what we did yesterday, except now we have subtraction showing up. So we'll go through a couple of these just to see what it looks like on a number line, different ways, again, of visualizing this subtraction process. So we'll jump over to the whiteboard over there. Okay, so our first one that we had, we were working with we were using a number line to find the difference between 8 minus 13. Okay. So again, creating a number line. So always start with our number line itself. We have the ends showing up, define where 0 is in the problem, define which direction is positive, define which direction is negative, and then we're going to write this out and scale it accordingly. Okay. Now I am going to scale my axes by 2s because I don't want to have to write a huge, big, long list of things. So I'm going to go 2, 4, 6, 8, 10, 12, negative 6, and negative 12. So we have our number line set up. We have a 0. We have the positive direction, the negative direction, and we also have everything scaled. So it's going by 2s, you can see. So again, our process for working with and writing this thing out in number line, we always start at the origin. So we start at 0. And my original value that I have been given is an 8. So it's a positive number, so I'm going to go in the positive direction by 8. That better arrow showing up in there. Okay. Again, I'm just putting these little dots in here to make sure we know where we're at. So now we are subtracting 13 from where we are here. So using vectors, again, we are going to be starting from where our last vector ended. And then we're going to be going in the respective direction we have that many units. So I'm going, looking at the negative 13, I'm going negative by 13 units. So I'm going to go over, see, 2, 4, 6, 8, 10, 12. So I'm going to be coming over to about right here. And then roughly about in there. So we have nothing else that's being added together. So we are ending at our point right here. What is this value? That's negative 5. We have our answer. Okay. So again, just that visualization of seeing this thing with a number line. And we'll take a look at our other example that we have here. So I'm just going to move us over. So that same page, but the second example. Let's say we started with negative 2. Let's put the actual -2 minus -6. Okay. So in that example, looking at the notes that we have right now, let's say we're solve this thing using any methods. We'll start with PEMDAS first because it takes less time to draw everything out and whatnot with that. So if I'm just going to solve this thing without a number line first, I'm seeing that I have double signs showing up with this. I've got a sign here, I've got a sign here. And those have been given to us originally. So, okay, that's fine. Let's take care of those and not have double signs showing up at all. Because it's kind of weird to hear minus negative or negative minus. It just, at least for me, doesn't make as much sense to work with it on that front. So with these double signs, I have a negative and a negative. So a negative times a negative is going to give us a positive there. So -2 is going to stay the same. Minus -6 is just going to become a +6. Again, we're just getting rid of that double sign that's showing up right here. That's all we're doing. So now that I have the double sign taken care of, I have -2 plus 6. I'm just going to add those together, and that's going to give me 4 for the final answer. Now let's take a look at this thing from the step where we got rid of that double sign. So let's make that thing into a number line because it's easier. Again, number lines are easier to do without double signs showing up. At least I think so. So let's work with that as a number line. Again, just for sake of seeing a visual of this. And again, beyond the scope of this particular section that we have, you guys are not going to be required to use number lines for adding or subtracting anything together. Okay, so again, we've got a number line set up. We got the origin, positive, negative directions, and scaling. We're going by ones. So we start at the origin. And my first number that I have is -2. I'm going in the negative direction 2 places. Over 2. A little too far there, but do that. And again, I'm putting these little dots so we know specifically where we are on the number line. So I went in the negative direction by 2, and then I'm adding 6. So I'm from there, I'm going in the positive direction by 6. So counting over, it's 1, 2, 3, 4, 5, 6. So about there. We are ending right here. Right at 4. Same thing that we had over here. So again, 2 ways of going through and visualizing these things. I think the number line is very helpful when we start with positive numbers and we go negative, or we have negative numbers and we're going more negative. So it's a very nice visual of the addition subtraction process as we go through that. And again, beyond the scope of this particular section, the few times I think it might come up on the homework, you guys are not going to be required to do and create a bunch of number lines for every single addition subtraction problem. So if you're worrying about that taking up a whole bunch of time on the test or a whole bunch of time on future homework, all of that, all of this that we're doing is not going to be a requirement that we're doing all the time. It's just showing up in a couple of these examples for that visualization on it. Okay. So we're going to jump back to the notes really quick. So we just worked with using the number lines with the subtraction process. And now we'll bring in a little bit more. So if we're working with our order of operations, now we can throw in some of these extra properties with subtraction in here. We've already worked with this a little bit, but we're going to go and take a look at both of these examples again, just for the sake of seeing the order of operations again, because PEMDAS is not going away whatsoever. I believe it's section 2.5 we have here that is going to be having, yeah, it's 2.5. 2.5 has operations, an order of operations, I should say, showing up again. So all of the stuff that we just did and all the stuff that we're going to be going through in 2.4 is all going to be coming together. So making sure we have that process following PEMDAS is absolutely vital. I can tell you right now, there will be a couple problems on test 1 where if you do not have PEMDAS down, you are going to lose a lot of points on it. Okay. So we're going to take a look at both of these in a bit more detail back over on the whiteboard. Again, just as a review of PEMDAS, because it's been a couple days, I think, since we had something a little bit more in depth. So we'll go back over there and we'll use PEMDAS to go through these. Okay. So we are told to simplify. So our first one that we have 4 minus the quantity 8 minus 6. And now again, we have the answer on the notes. We're assuming we don't have that. We're going to go through this process. So again, I'm told to simplify, which means when you see the word simplify, you see the word evaluate showing up anywhere in there, your first thought should go right to PEMDAS every single time. Because more often than not, that's what we're going to be using to go through and solve these things. So I'm just going to write that in for myself. Again, you don't need to do this. This is just the way I go through and organize it for myself. Keep track of how I'm going through these. So first things first, parentheses. Do I have any parentheses? Yes, I've got some right here. When we go inside of parentheses, we restart PEMDAS all over again. So I'm only looking at 8 minus 6. So inside a set of parentheses, I don't have any parentheses. I don't have any exponents. I don't have multiplication, division. I have addition, subtraction. So I'm just going to combine that 8 minus 6. And that's going to give me 2. Now I'm looking at PEMDAS and saying, all right, do I have anything else going on inside that set of parentheses? I just have the number 2, so no. Can't do anything else with that. Parentheses are done. Do I have any exponents showing up? Nope. Do I have any multiplication or division? Very, very technically, I've got this negative and a positive here. So let's take care of that and just get rid of the parentheses. Multiplication's done. Addition, subtraction, I have 4 minus 2. That's just going to give me 2. So we have our final answer there. So we'll take a look at our other example, that same page. Just moving us over here. So we had negative 7 plus 3 plus 10. 3 minus 10, my mistake. Okay, and again, we're told to simplify. So again, we're starting with parentheses. I have parentheses in here, so all I'm going to do is look inside that set of parentheses and restart PEMDAS all over again. So inside that set of parentheses, I don't have parentheses showing up again. I don't have exponents. I don't have multiplication, division. I have addition, subtraction. So I'm just going to do 3 minus 10. That's going to give me negative 7. I'm going back to my checklist. I'm looking inside my set of parentheses that I still have. It's just the number negative 7. I can't do anything else to simplify that, so parentheses are done. I have no exponents, multiplication or division. I do have this double sign showing up right here. So let's get rid of that. So a negative, or a positive and a negative, it's going to give us a negative result. So I'm going to have negative 7 minus 7. So again, all I did was just take care of the double negative there, make it a single sign, or double sign there, make it a single sign. So now I have negative 7 minus 7. So it's going to give me negative 14. We've got our final answer right there. Okay. So again, just going through that simplification process using PEMDAS. We are going to be using this more. It's not going away. And again, it's going to be a fairly decent portion on the test, so make sure you have that nailed down as well. So let's jump back to our notes here. So the last part that we have showing up with this section is application problems or story problems. And those are not going to be going away. We are going to have story problems throughout the rest of this quarter. So again, when we were going through these, we kind of talked about this a little bit earlier on, but I just want to go through kind of a reminder of how to go through this, or at least my recommendation of when you're going through these. Read, reread, reread again, and repeat as you're going through these. I cannot emphasize this enough to you guys. A lot of people will try and read a paragraph of text once, create an equation, and just go. And it's not easy to do. So read the problem multiple times. Pick out pieces of information that you think are important, things that aren't important. Get yourself familiar with what's going on in the problem, but do not rush that. It's a very important step in this overall process. Draw pictures if you need to. You don't need to be an artist. This is not an art class, so I'm not going to be grading you guys or grading your scratch work on how well you could draw a boat or how well you could draw a car or anything like that. But making that visual for yourself is very, very helpful. And the reason I emphasize doing this one is because I'll pose this question and you answer it internally for yourself. Are you a visual learner? And if you're answering to yourself that, yes, I am a visual learner at some capacity, I think everyone is to some degree, then why not draw a picture? Why not create that visual for yourself? It's going to be helpful as you're going through this thing. Define and label variables and values as they've been given to you. Maybe that includes crossing them out from the problem if it's useless information. Maybe that means, okay, I've drawn a picture of this thing, and now I'm going to put that information somewhere in my picture, labeling that thing. It goes a really long way with keeping our work organized. And then from there, then we can start creating equations and then check if that equation is reasonable with the given problem. So that doesn't mean that I'm going to create an equation, I'm going to put in some numbers, and then I have to commit to using that equation exactly as it is. No. Write something down, make some modifications to it, reread the problem, see, does this equation that I've made make sense with the problem that I'm working with? Maybe you need to adjust it a couple more times. But again, a lot of people want to go with, I read it once, this equation seems reasonable, I guess I'm going to put some numbers in here, and then I'll solve what's left over. And you don't want to be doing that. Once you have an equation set up that you do like, then you can solve it for whatever you are specifically looking for. Maybe you're solving for a variable. Maybe you're solving, maybe you're just evaluating something. Maybe you're just simplifying an expression, whatever it may be. Then you can solve for whatever's left over. After you've done that, check that your answer is reasonable with a given problem. Again, if we're working with the idea, kind of the original example I gave you guys, if we're working with finding the distance between point A and point B, and you go through and solve an equation that you've created and you get a negative answer. Well, mathematically, it's fine, but in the context of the given problem, we can't have a negative distance. So it's not a reasonable answer for the given problem. Okay? So I want to bring you guys' attention to this as well. A lot of people, and I've already got a few people that are asking about this, having some problems with translating these story problems over into equations. So I'm going to bring us up here to the English to Algebra document. I think this is especially helpful with subtraction because ordering absolutely matters when working with subtraction problems. So again, this English to Algebra 1 document, you guys can go and view this, download this, print it out, whatever you need to. I give this to my Math 62 up through Math 97 students every single quarter. And it's very, very useful. Because translating English into algebra is not the most intuitive thing to do in the world. If we're taking a look at subtraction, for instance, there's how many different ways that are listed here to say something minus something else? So keeping track of all of this is not the easiest thing to do, especially when we get into the subtle parts. It's kind of reference our two examples that we have here. The subtleties between having, let's say, 10 minus m or m minus 10. And there's a huge difference between how we write this thing out. We're actually working with a problem. So if you do need or want to take a look at these can be found on our Canvas site. Go into Files, Useful Files. This is English to Algebra 1 PDF. So I highly recommend if you're going through this section or any of these chapters and you're saying, I'm struggling with trying to figure out how to translate what I've been given into some kind of an algebraic expression, go download this file for yourself. That's why it's here. I want you guys to use it. Okay? So we'll jump back to our lecture notes. And this is pretty much everything that we have for 2.3. It's just a fairly straightforward, I think, addition to what we did in 2.2. No pun intended. So we're going to move on. We're just going to get started on the 2.4 material. We do have that listed on the syllabus as we might get started on that today. So let's do that. If we can get ahead a little bit, that would be good. Set ourselves up with some extra time down the road. So we'll see how much we can get through today, and then we'll pick up from here tomorrow. So we'll start first and foremost with some properties of multiplication and division of integers. Again, most of these are related to multiplication over anything else, but these are our first ones here. But they are extremely useful when we get to stuff down the road, especially when we want to manipulate some equations or expressions to work with numbers a bit more easily. So our properties of multiplication. The commutative property tells us that the ordering of multiplication does not matter. So if we have a and b are values, then b times a is the exact same thing as, or a times b is the exact same thing as b times a. So you can put some numbers to this if you want to. Let's say we have an a value of 2 and a b value of 5. All right, well, what's 2 times 5 going to give us? It'll give us 10. All right, well, what's 5 times 2 going to give us? If I reverse that order on it, well, that's also going to give me 10. So it's a really nice part with the commutative property of, again, the ordering of multiplication does not matter. So you can move these things around, go back and forth with them however you want to, if everything is multiplying together, which is really nice. Our next property that we have is the associative property, which tells us if values are multiplying, then grouping does not matter. So our grouping symbols are parentheses or brackets, depending on how we want to organize that for ourselves. So if a, b, and c are values, then if I do the quantity a times b times c, it's the exact same thing as saying a times the quantity b times c. So if values are multiplying, everything is multiplying together here, then I can group these things and say I want to multiply these two things first, or I want to multiply these last two things first, and then I'll work with whatever's left over. You could also kind of combine these and say, well, using the commutative property, everything is multiplying. I want to rewrite this and say, well, I want to put this a at the very end, and I want to go b times the quantity c times a instead. You could do that too. So you have a lot of ways of manipulating values and variables being multiplied together with these two properties. It's very, very useful. So we're going through and solving some problems and equations moving forward. So then we have the multiplicative identity property, which tells us that any value multiplied by 1 is the original value. So if a is a value, whatever it may be, think of your favorite number, then a times 1 is just going to give me a. Using the commutative property here, and 1 times a is going to also give me a. So again, the ordering doesn't matter with this. We might think, okay, well, that's, yeah, duh, anything times 1 is just itself. Yes, but when this was first discovered, created, and formalized, this is a very, very special property. So that's why it has this this special name attached to it of the multiplicative identity over anything else. Okay? So our 3 major properties that we have showing up here with multiplication. And we'll get into some of the other kind of more generalized things here. But remember that multiplication is just repeated addition. So if you ever are in doubt of how we're getting some of these numbers or how are we getting any of these, you can expand this out to just be addition of a number, a certain number of times. I would recommend not doing that purely to save yourself some time and some headache. Use a calculator if you need to. But at its core, that's what multiplication is just repeated addition. Now signs matter with multiplication. So if you are someone who has gone through these problems and we have, okay, so I can't remember if a positive and a negative is a 0 or a negative times a negative is 0, or I'm just not, I can't remember that. Try to make a little table here that might help you out with that. So if we are going to assume that A and B are values, again, choose whatever number you want, then A times B, the A times B results are going to be the following. So if we have A as a positive value, and if B is a positive value, then a positive times a positive gives us a positive result. If A is positive and B is negative, we're going to get a negative result. If A is negative and B is positive, then it's going to give us a negative answer. And if A is negative and B is negative, the result is going to be positive. So all that this does is this table is here to tell you the sign of the answer. It does not tell you the actual numerical value, but it tells you the sign of the answer. And when we go through some of these problems later on in 2.5, where we have a bit more that's going on, it's really nice to be able to look at two things multiplying and just say, okay, I'm going to take this thing in parts. I know I'm going to probably have some gross numbers showing up. I just want to work with what's the sign of my answer going to be. And we can use this table to help us out with that. So once we know the sign of our final answer, then we can work with the numbers. And that's what I recommend using this for. I also try to make a general rule of thumb if you're trying to do any of these sign operations and remember what the result is going to be. If the signs are the same, the result is positive. So we have positive, positive here, negative, negative, and that there. If the signs differ from one another, they're different. One's positive, one's negative. It doesn't matter which one's which. Then the result is going to be negative. So trying to get these in here for you guys because I think this is really, really helpful from working with and having to do work with signs. So I would also recommend, I have it written here, is you will need to know your multiplication tables from 1 times 1 up to 12 by 12 by memory. You don't really need to have it memorized in the sense of like you're going to fail or succeed in this class based on knowing those that multiplication chart. It's not going to be the case. However, I would highly recommend you get this nailed down because the last thing you want to do is show up for the test, retake that, and have to use the calculator for everything that we have on here. Be able to do a fair amount of this multiplication in your head. I think there's a few apps that you might be able to find if you go into the app store of just like multiplication flashcards or anything like that. Just go through and drill on those for a little bit. And even if maybe you don't have 1 through 12 nailed down, I would say at least have 1 through 10. Best you can, because that's a good chunk of these things that you're going to want to have memorized. And again, if you have anything larger than that, 13 times something else or 24 times some other number, you don't need to have that memorized. Just use a calculator if you can't do that mentally. I think this is the stuff that I would recommend having memorized and having the ability to do that on your own in your head. Anything beyond that, yeah, use a calculator. There's no need to memorize anything beyond that. If you are someone who has your multiplication tables memorized up to 13, because I've met a few people who in previous experience, they've learned all the way up to 13. And if you're in that boat, great, fantastic, good for you. If you're not in that boat, again, it's not required. I would say at the very least have everything up through 10 by 10. 12 by 12 is preferred, but at least 10 by 10 memorized for yourself. Again, saves you a lot of time on the homework, saves you a lot of time on the test because you will have time limits on tests. It's one less thing you have to go through and type into your calculator. Okay. So going into the distributive property, we already worked with this a little bit, but again, it should be a bit of a review here. We're going to let A, B, and C be values, whatever they are, positive, negative, whatever. Then if I have A times the quantity B plus C, this A is going to distribute through to each term that we have in here. And my result is going to be A times B, whatever number that would be, plus A times C, whatever number that would be. Okay. And I'm going to make this emphasize as best I possibly can. I don't know any other way beyond this to give you guys a warning on this. This only applies with multiplication. It does not apply with exponents at all. When we get to working with exponents later on, this is the most common thing that shows up. Well, if I have the quantity A plus B, all raised to the second power, we do not distribute exponents in any way, shape, or form. So this 2 up here is not going to go through like we have with our result here. If I have x minus 4 all inside of parentheses raised to the 4th power, this exponent does not distribute through to each of these like we have written out here. The distributive property only applies for multiplication. It does not apply to exponents in any way, shape, or form. So I don't know how I can emphasize this enough. I could draw on this thing, put the stars, anything. This is huge. I've seen many people lose a lot of points on tests because they do not apply the distributive property correctly. It only works with multiplication. It does nothing with exponents. So never apply it in that capacity as we're going through these. Okay. So we're getting to, oops, mouse here. So moving on to a couple other parts here, and then we'll stop here today, because this is actually a good chunk of the 2.4 material. So multiplying by a -1. So multiplying a number or a variable, should be noted this works for variables also. Multiplying a number or variable by -1 only changes the sign of the original thing to its opposite. The numerical value stays the same. So multiplying by a -1 just changes the sign. So if I'm starting with -1 times A. My A is originally positive. What is a negative times a positive? We'll go back up here just to our table. A negative times a positive is going to give us a negative answer here. So this A, which was originally positive, is going to now be a negative. If I have -1 times negative A, again, our A value is starting off as a negative times a negative is going to give us a positive answer. We're just going to have a positive A left over. Again, a fair amount of this seems like, okay, well, yeah, that seems pretty straightforward, potentially, if that's you that's thinking that. And yes, it is a pretty straightforward idea overall. This comes in handy when we are working with equations and we're solving things down and we get -x equals some other number. How could I get that negative taken care of in front of the x? Well, we could multiply by a -1 to just change signs. So it seems like a pretty straightforward idea here and now. At least I'm hoping it is, because I think it is. And we want to make sure that we are applying this properly when we have the opportunity to make our lives really easy. So we're making sure we don't forget about this moving forward. So I think this goes into division for integers here. So we're going to stop with right here, we're going to start with multiplying, and we'll pick up tomorrow with division of integers. And we should be able to get through most, actually we'll get through all of it tomorrow. That's the plan. So we don't have a whole lot left to cover with this. So with that, I'm going to end our recording here, and then I will open things up to any questions that you guys have regarding the lecture notes or anything else.